While you're writing, let me ask those of you that have finished. Look right up here. What you're trying to prove here. Is this an SSS, SAS, ASA, AAS kind of question, or is this a CPCTC kind of question? It's an S's and an A's kind of question. Look, you're trying to show the two triangles are congruent, and that can only happen, two triangles would only be congruent by these reasons right here. Okay, if you're using CPCTC, it would have two segments equal or two angles equal. It have parts of it equal to each other. All right, so obviously the very first thing we're going to write is our given. SU is parallel to AC. What does that word parallel give you? What comes from parallel lines? Look over here still. What comes from parallel lines, these lines with parallel markings right there? Alternate interior angles. So anytime you see lines of parallel, look for alternate interior angles or corresponding angles. And then we also know that SU is congruent to AC. Okay, so the first thing you do when you're trying to do a proof is you deal with everything that's given. There's two things to do. And you look for keywords and you look for marks that you can make on the parallel on the diagram. Okay, so in this the keyword is parallel. Parallel means that we're going to find when two things are parallel, means we're going to look for alternate interior angles. That's what parallel lines do for us. And so let's go to SU and let's make parallel marks. SU is parallel to AC. SU is congruent to AC. There's nothing you can do with that except just mark it on the picture. Make a congruent mark right here. SU is congruent to AC. So that gives us a little S already. You guys can do this. Number two, you guys can see this. You guys probably already see it. Tell me something you see. Alternate interior angles. Start from this parallel line marking and go to the transversal. Start from the other line where the parallel mark is and go to the transversal. What does that give us? What two things are congruent? Angle 1. That's right. And that's the alternate interior angles theorem. So look at what we've done so far. You have, from the picture, you found alternate interior angles coming from the parallel lines. What else do you see there that hasn't been marked yet? Wait, let me label that as a little A for angle. What else do you see there? Reflexive. Tell me the letters that the reflexive mark goes on. Good. Okay, so CU is congruent to CU, that's right. And you guys already said the word reflexive, so now you just have to write it down, reflexive property. And that represents the side that we did right there. So now we're basically done. We're trying to prove the two triangles are congruent. And what method do we have of showing that here already? Actually, it's S. There's an angle in there. Where does the angle go? It's S-A-S. That's right. S-A-S. So we have two triangles congruent. Triangle S-U-C is congruent to triangle A-C-U. When they ask you to prove triangles, you can just go with the order that they gave you. You don't have to make up your own order. Okay. That was the proof. You start with a given, any markings you can make, or any keywords that lead you somewhere. Next thing you do when you run out of things to do from the given, you look at the picture, and you'll be finding either vertical angles or maybe a reflexive piece. Then you look for connections between all the steps. That's when they get a little longer. And the final step is to write what you proved. And for now, our endings will either be ASA, SSS, these shortcuts, or it'll be CPCTC. If you're showing the two triangles are congruent, it has to be one of these. All right, that's just a hint to help you. All right, let's try another one where I walk you through it a little bit. Let's see if we can get to one where you'll do it on your own. So copy this one down though. And as you're copying, think about the key words. Think about what's congruent there. And what is a key word in that given piece right there? And these are the things to think through. What you're given, it's given to you for a reason. At this point, they're not going to throw any extra givens in you that are in the way. Look at your picture. You're looking for vertical angles, reflexive sides. You're looking for things that could be helpful. You're looking for connections between all the steps. And at the end, you're either going to use CPCTC or angle, side, side, those shortcuts. Looking at this example, before we do anything, look at that ending. Is that a CPCTC kind of ending, or is that an angles and sides kind of ending? Angles and sides. Good, because it's two triangles. So number one, MO is congruent to PO. That's a very good clue. We need that. And the second thing is that not number two though. NO bisects MP. So the first thing you do is mark what they gave you, and then secondly you look for the keywords. So they already told us that MO is congruent to PO. So go to your picture and make MO congruent to PO. That was just a reason that was given. But look carefully. They gave you the word bisects for a reason. What does bisect do? Cuts in half. So look at this. NO bisects MP. Which segment, which two letters is the one that's actually getting cut in half? The N to the P, right? This segment. So you go from N to P and you cut that one in half. NP gets cut in half. So that means this half equals that half. Okay, one of the mistakes people make is that they go backwards. This is doing the cutting, but NP is the one that's actually getting cut in half. But if you see that, you have to write it. MN is congruent to NP. Somebody knows the reason for that. Somebody please tell me.
Definition of bisector.
Excellent. Definition of bisector, because that's what bisector means. When you're making a proof, all you're doing is writing out the reasons for what your brain kind of already knows just by looking at it. You guys took a quiz where you could look at all these things and you could say SAS or SSS, but the proof is just writing it out. So we've used our keywords, we've made our markings, now we move to the picture. Look at that picture and what's the one thing that stands out to you in there? Reflexive. NO is equal to NO. NO is equal to itself. And someone already said the reason for that one. He said reflexive. That's not all right, and then we're basically done. We said that these triangles were going to come from sides and angles and things like that. Well, what do we have right here? What do we have here in order of letters? SSS. And whenever you have SSS, you're going to state the two triangles are congruent. You don't have to figure out which ones. It's right there. Triangle MNO is congruent to triangle PNO. So the main things. Look at your keywords. Look at what you can mark. Look at the picture for things like vertical angles and reflexive. Look for connections. That one's going to really come later. But for your end steps for today and for tomorrow's quiz, your last step is either going to be the letter combinations or else the CPCTC. And let me show you one more where it's going to be CPCTC. And let me show you the difference. Then I'm going to put, if you started on your homework ones. Okay, I want to find one that has something different. This one's good. Actually, let me compare it to the next one and see. Nope, this one's good. Okay, copy that in. This will be the last one for our notes. as you're writing, think about what the keyword is that you're going to use for your next step. Don't say it out loud, just think about it. What the keyword is that's going to help you get started on the next part. Okay, this one, I want you guys to realize that I'm going to change this. Because I want you to see this one, the way it's written is an S's and A's kind of problem. And I want you to have one example where it's not that. So if you did it in pen, that's okay. Just cross off. Or if you did it in pencil, that's okay. What I want us to end up proving, because you're going to see something like this on your homework, and I don't want you to be stuck without having seen one, I want us to prove that JH is congruent to CL. Okay, so if you're not showing the two triangles are congruent, if you're proving that parts of the triangle are congruent, this is going to end with what then?
CP.
CP, CTC. Good. So number 2. What was the keyword from the given that we're going to use for number 2? Midpoint. Good. So the midpoint means that something is cut in half. What segment, what letter is being cut in half? JL. That's where it's being cut in half. So we're allowed to say that this half, JB, is equal to what? BL. JB is congruent to BL. Definition of midpoint. Am I done with the given? Have I used everything that I could there? What's still there that I didn't do anything with yet? That's next. That's good. But what's in the given that I haven't done anything with yet? I didn't do this one yet, did I? J. So do that. Go to J and mark it congruent to L. Anything that's in the given, make as many markings as you can, and then use the keyword. Now I'm done with the given. I've done that one, and I've done midpoint. And so, was it you, Daniel? Someone said that there's vertical angles. Be careful when you label them. Because the B is the vertex, and the B has to be in the middle. So label it as JBH is congruent to, label this one for me in the right order. Put B in the middle because that's the angle. Give me the other vertical angle. LBC. Good. Angle LBC. And vertical angles theorem. Don't just write vertical angles. That's not a statement. But the vertical angles theorem is a statement that vertical angles are always congruent. So we've done our given. We've gotten everything we can out of the picture. We found the vertical angles. So next, we look at what we have. Keep looking at your picture. Look at connections from the things you already did. And what do you see right here? I think someone said it. Say it loud. Angle, side, angle. That's right. Angle, side, angle is next. So we have angle, side, angle. And that makes congruent triangles. JBH is congruent to, and since they didn't, in our case from what I changed, they didn't tell us to prove triangles, so we have to put it in the right order. I chose JBH. If I started with J, what letter matches with J? L. Has the same mark. And then I chose B. Which letter matches with B on the other one? B, and then the C is last. Alright, but what always comes after congruent triangles? Yeah, and when I say always, I mean mostly. Alright, CP, CTC. So because these triangles are congruent, I'm allowed to say the JH right here is also equal to CL. All the parts are congruent because of CPC.